shouldn't fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired of yesterday. Fada, fada. I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up. Climbing and climbing, I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days, but it doesn't mean I lost my styling. Where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time stands still, a king without his crown. Now I'm breaking and you're faking, girl. You never made a sound.
So hello. I think it's a bit too loud. Yeah. Hello everybody and welcome to our first live stream where I'm talking in English and English only. Please tell me how is our sound. Isn't the music too loud? You can comment in Russian, by the way. I don't really care. Yep, everything seems to be okay. Yeah, I'll turn it down a bit because it's too loud for me. So let's start. I hope it's going to be great. Yep, so what's our deal today? Today I'm going to find out what's the way one of my all-time favorite games plays music. So this is the game. This is the Wikipedia page. This is the screenshot. If you're not familiar, and I think you're not, because it's rather an old obscure game, and all of my viewers are much younger to remember this. So this is the demo of music. We're going to find out how it's played. Let's take a listen. So something like that. It's a primitive PC speaker music, not really great or anything, but I really like it because of nostalgia. So I guess we're going to find out how it's played, where it starts, so we can just play it by ourselves without actually needing a game. So for that, I've prepared some documentation for PC speaker, how it should be operated. I also have my sources where I kind of know how to make it sound. So this is going to be a huge clue in searching for the answer we're looking for. I also have some additional documentation we might need about interrupt controller, timer, and so on and so forth. So I also have this nice screenshot which shows like addresses of interrupt vector table, and so this is also a huge clue in reverse engineering. I don't really like the absence of viewers, but it's okay. This stream is more for me than for you. So let's skip this track. It's too boring. Okay. Yeah, I know you're here. That's great. So, let's start. We have a project in Ghidra. I've already poked a bit, so I kind of know what some parts of it doing, but it's still not really enough to like get the whole picture of music and how it's played. Most importantly, where it's stored, because like I know how to play it, but I need like to find where are the notes stored, so I can like read them back and play. Just fucking stupid music. What the fuck? Yeah, like let's make it super quiet because it's stupid. So we need some kind of search tool. Yep, and we are going to search for out instruction. And for you who don't really know assembly, out is the way for like writing some value to output port, so it's the way how PC speaker should play sound. And I already have some of the procedures named, but I am not really sure it's correct or anything, so it's still like a mystery to me how exactly it should be played. So like here is one of the possible routines to which plays like song or at least a note, and I've been trying to figure out where is the frequency like is taken, because you need for playing certain frequency you need to divide this number by your frequency that you need to play. So this division, I think it's like was already done at some point. So like I'm just reading some buffer with prepared values, that is values that has been divided. So and I'm just saying, well, PC speaker, please play this, and this or with 3 kind of sets it to on position, I think. It's kind of not obvious, but you need like bit 1 to port 61 hexadecimal to like set it to on position. But I think like doing something like that does it automatically, maybe? I don't know. So let's find out. Yeah. So we need to find out what are the values like at this exact address, but it's too indirect. You see, like we have a pointer here, it's dereferenced and then bit shifted like once to the left and then some other value is added to this, and it's again dereferenced, so it's like some complex value. I don't really know where to start looking. Probably so like I've kind of figured out that BL is the value that located at this address, and then this value is it's probably some kind of index. It's getting like shifted by 1 to the left, and then some other values added. I don't really know, because this C decompilation doesn't really help, but this can help, because we're making sure that our like most significant part of the 2-byte word is empty, so we only have like BL that is set to some value, then we're shifting left by 1, and then we're like adding this address to this value, and then moving the 2 bytes to the AX, and then like playing this frequency, because as you see here, like this step was already done, has been done already at some other point, and I know like 4 or 5 places where this happens, so it's kind of an initialization step that like forces our interval timer to like output a square wave with some bunch of configuration around it. So we're not really interested in this value, because it's exactly the same, so I know for sure I just know what it does, so it's not a big deal. But this value, on the other hand, is like very interesting, because it's frequency. So these values are located at let me see, at like this address, so we just need to find where like this is set, and this what are the meaning of all these values. And probably there are like a bunch of functions which play sound, because in this game you need to play 2 songs. First one is played after game is started, so we recently heard it, and I'm personally most interested in this particular song. There is another song which plays at the main menu screen. It's different, and you also need to play sound while like you're driving, because it's a game about race, and you need to like play engine sounds and stuff like that. So probably there are like 3 separate functions for that. Like probably this one plays some of the songs, and 2 other ones like plays main menu song, and plays just one sound corresponding to like motor, car engine state or something like that. So let's start to search for these values. And by the way, like this initialization might help, because like address 080A and 080C are like not very obscure addresses, so we probably can search for them. Let's see. And it found only 1 hour comment, which is not very helpful. Memory block types, all blocks. Yeah, it's not very helpful. Well, I know that in one of the initialization functions, let's see, we have like this function, which is called from one of these functions, and for example, this one is it's not very useful. Like one of those functions is called from some other function, which like might have to do something with these two addresses. I just don't really remember which one. Oh, yeah. So, like, this function is super helpful because you see, it's doing a bunch of initialization stuff. Like, probably we're not really interested in these two addresses, but like, here are our exact addresses, and they are loaded with values of like which are passed by parameters here. So it's probably, I've named it like set initial sound of sets. It's probably what it does. So it's like it loads which song to play, but I don't really know. Probably it's just some other initialization. Maybe it's related to one specific song. Maybe it's used like in driving sections, but we'll see. So we kind of know which values are loaded in these addresses, so we can like play them later. But what are these parameters? I have no idea. Maybe we can like copy this block in some like editor. And leave a comment that this is probably where song of sets are loaded. But like for such thing as song, probably it's not very useful to like call a function to load some bytes on these addresses. Maybe it's used when driving, but let's see. So it's called here. This one looks very much like some sort of initialization because it's like setting a bunch of addresses, calling a bunch of functions, but doesn't really do anything. So it installs our handler for like PIT for this thing. It sets addresses like to these two, so we kind of know what are the parameters. It's called let's see. So like this one is loaded with this address and this one is loaded with this. So because like our play function, where it's so here it uses like this formula, I suppose. Oh no, this is wrong. This is not what it's supposed to be. So I've kind of... Why it's so loud? Music is very loud. So let's see. Like this comment is wrong because like BL is this value, not what I wrote later. So this one is also wrong then, because it's like BL shifted by like 1. So let's see. So it's like BL, then added this value, then the reference. So okay, we need to like calculate this address probably, because it's like what it is. Yeah, so we are loading value from like this one. If byte at this address is 0, we're doing something. Yeah, I'm sorry, if it's not 0, we're like here, and this is part where music is played. So okay, then we're loading byte from SI. We're setting like BL to byte PTR from ES SI because yeah, so like this one is correct because it's exactly what it does. It gets value from this address, so like bit shifted by 4 and then value from this address, so it's like this one is added. So if I'm doing this correctly, the resulted value is plus this one. So let's use something like Python to compute it for us. So it's like so it's like this address. Okay, so like let's suppose our music is stored here. So what about our access function? Let's see. So so our values are like stored here, but each time we're like before we're accessing this, we're doing something like, so our BL it's really strange because like here, yeah, we are moving this value to BL, but isn't it too large? So oh no, BL is value at this address, so like BL is this but dereferenced with so like it's byte. Let's do it more correctly, like that. So this is value of BL. We need this address, and then like we're dereferencing it. So this is our first. So it's probably of type something like char star star. So it's a pointer to byte array, and we're dereferencing it. So we're getting the actual address because later we're going to dereference it again, so it must be a pointer. So it's like this nonsense. But the question is, what is the value here? What are the bytes? Because we need like a 2-byte value out of here, I suppose. Yeah, because like we're treating this as word pointer, so it must contain at least 2 bytes starting from bx plus 084a, and then we're loading value at this address to ax, and then we're playing. So it's only a pointer, which like makes things a bit more complicated than they should be. Okay, so let's actually search for these addresses, I suppose. Like these ones. Oh, you see, like, this is great, because this function, read entire file, is actually like what I think is read entire file, is uses this value, and what it does, so it's like, where is it? So like this value is not really dsbx, dsbp. So like finding this value here is really good, I think, because also, but it's like it seems like it's some base. Okay, it seems that it's not like the actual value of something, it's because like what's let's get back really quick to this part. So I think this value is ES value, so it's like a segment value, because okay, it actually makes sense, because like if this is like ES is like this value, then this address is actually what we're looking for, because like segment is just, yeah, whatever, like segment starts at some position, and then all the values of interest are like offsetted from this segment. So it's actually pretty obvious here, because we're using like this value as segment pointer. So like this is an offset, and we know which offset it might be. So like this byte, like this address is probably what we need to find. I hope we are going to find it. Not really. Not really. Why like too few results? I mean, in function set initial offsets, it's also this value that is loaded. No? Like what? Oh yeah, it's it's exactly this. It's like a call to set initial offsets, and this is like parameter. Like we are pushing this one, push ds, which is probably like if it's a segment pointer, it might be also this value. So we're calling set initial offsets. We're setting like these values here to our parameters. Yeah. It makes sense. I have no idea what this is about. And what is? Yeah, it's called entry. So I suppose it's like the first function that is ever called. And it makes sense, because like we're installing a bunch of handlers, we're setting initial offsets, and probably like later we're going to play some stuff. No? 5e f0. I was hoping to find like probably some like some function which reads files or does something interesting with them, like is going to have this address. So it's actually this yeah, it's this value is used like all over the place. So it's push ds. So probably this value is also like a ds value. Let's mark it like question mark equals, because I don't really know whether it's a data segment or not. Well, I suppose it might be. So whereas from what I understand, before we're calling this function which initializes 800A with values like with these values, we're like passing data segment here. So like this is an offset, then we need to like really search for this address, because it's like explicitly passed here. So this one is an offset where we might find the music. But unfortunately this search like found nothing, which is lame. And probably it hasn't disassembled it like in full. And we also have like this strange section which doesn't look like a program at all. Like what is this even? Maybe this is like actual raw bytes, not a code section. Yeah, and this is totally some garbage. Uninitialized memory. Yeah, like this doesn't make any sense. It's probably some data. So let's reinterpret the whole section as just some bytes, because I think it's not really a code section. So like starting from here all the way, maybe we can select it differently. So like starting from here we need like shift and like end. Yeah, like that. So we should like reinterpret it as just data with bytes. I don't know how to do this in here. So disassemble, clear code bytes. I don't know how to do this. Yeah, something like that. So it's not a code anymore, it's like data. Yeah, and you can see that Mona, it's probably some strings. Can we just, yeah, data and like characters? Yeah. So Travis, yeah, it's some strings. Vito, yeah, Peter. So it's just some random data. I'm fine with that. Maybe we can like terminated C strings. Yeah, much better. So it's like some like mangled names of countries like Brazil, maybe Monaco, Canada, Britain, Germany, Italy, Japan. So like Travis, Bruno, Don, Tony, with some additional data, probably pointers to something. It's car names. Yeah. So we found some interesting like data segment. But like, does it really contain our music? Some kind of garbage here. Maybe. Like music isn't here somewhere. And because like intro song has some repetitive patterns, we can like try to find out. Yeah, this is like the whole alphabet. We can try to like figure out whether it's like really music bytes or not by just looking and finding like notes and stuff. This is all white spaces. Not exactly, probably it's more like an escape codes. Yeah, this is like strings. You see, like this one is like displayed after race is finished. Interesting. So each node is a 2-byte value. No, oh yes, it's a 2-byte value. So like we need find like where 2-byte values may be. So we have this address of 5FAD. Can we like find it? 5F? No, it's uninitialized. Even if it's like is supposed to be here later, it's uninitialized. Sound off, music on, music off, keyboard on. Probably some kind of controls. I like had no idea you can turn the music off with a button press or something. Very interesting. Yeah, like imagine music is somewhere there and we just can't interpret it like music. End of phrase. Yeah. More strings. And this song is and this song is like very similar to to this intro song, like with these beeps. Very funny. Like for a second I thought the actual music from this game started to play. Yeah. So okay, for me it's just garbage data with some actual C strings hidden. Like end game, enter your name, error opening file, fastest lap times, high score, status, speed stuff. Oh, that's actually yeah, that's actually names of files. like see this .snd extension? It's like this one. So maybe if we search for like where this so extract B, extract C is also file names. So probably if we like search for where they are used, we can find. So let's start with SND. We need address for F77. Like for F77. Nothing. How embarrassing. Yeah, probably it's... But to use it in pointer, you still need to like load it with some value. This is probably like when game is crashed or something, it's some kind of format string. Calibrate your joystick. This is actually this one is played is displayed only when the music is playing, and like if on this screen you press escape, this shit is actually displayed. So we can search for this address to like try and find out where exactly like escape key press is handled. And it's nothing. Stack overflow, integer divide, not enough space. Runtime error, floating point not loaded. This is like error strings, obviously. Yeah, and starting from this one, it's all uninitialized. And very nice, actually. It gives us some idea of what is happening. So we just need to find where these addresses are loaded. Probably it's not a correct address here. I suppose. Like, let's search for int16, and probably no, not like that. So int16 is a way to handle key presses. So but like we also have like IRQ1 handler. It's not IRQ1 handler. It's IRQ0 handler. So int16. Let's start from the beginning. We can search for specific int16. Let's see. So it's int16, okay. Let's actually see what this will do. I have a book which gives me a reference to every interrupt imaginable on old IBM PCs. So it's int16 with AH loaded with 1. So it's check if key ready to be read. So we're like loading this, invoking interrupt, and then jump if not 0. Output 0 flag is clear. So if not 0, jump here. So yeah, if 0 flag is clear, we're like returning 0 and like returning 0. Yeah. So let's change signature a bit. So this is probably should be called is key ready. So like is any key. It's not like if some specific key is ready, because like we are not passing any parameter, and in16 function 1 doesn't require any parameter. So it's like whether anything is pressed and we can like read it. Because yeah, you see this AH0 and function 0 is read key from keyboard. So if key is ready, we are reading it, and we should also return it probably. So int push AX call. Yeah, we are calling some other function probably which handles key press. So let's for fuck's sake, why music is so loud? So let's like name it like that for a bit. Yeah, this function, what it does. So it outputs AH as a standard keyboard scan code, and AL is ASCII code. So we're comparing some bytes. Yeah, like whatever. Jump with 0, so it's now we are enabling interrupts, comparing some shit again. It seems like this is our interrupt handler probably, but it's rather stupid one, because like why do we need in16 if we can like install? And this game, by the way, installs its own interrupt handler for IQ1, so it knows precisely when key is pressed. So I just don't really know the purpose of like this whole thing. Like what is this even? It's some stupid assembly. So we're moving stack segment to BX, data segment to CX, and if stack segment is equal to data segment, if not equal to, then we're just returning. And otherwise we're doing some other shit. And why in the hell stack segment is supposed to be equal to data segment? Let's see. I'm really interested in what this function does. So it compares some shit to 0. If it's 0, then we're going here. If not, we're just like returning. So if it's 1, I'm sorry, if it was 0, we're loading it with 1. Then doesn't remove from the keyboard buffer. So like it's probably some sort of toggle. If like if this is 1, so we're not doing anything. And you see, like if it was 0, we're loading it with 1, so it's like temporary, some sort of temporary variable. We're loading it with 1. We're enabling interrupts in both cases. So then we'll do some more comparisons with parameters. So it's like this is actually probably like why it says it's a parameter when pushing. Yeah, so we've pushed AX it's the like scan code and ASCII value of pressed key. So we're comparing it to so we're moving it, so this is like our key that was pressed. So we're checking whether it's 0. So if like how if it's extended ASCII, so AL is 0, and so this is 0. Like this branch is like about extended ASCII, but who cares, I think. So jump of 0 where? Here. So like this node handle extended ASCII. Like we escape is not an extended ASCII, so we're not probably interested in it. Then we're doing AND with BX. 7F. 7F. Yeah, so if it's break code, we're like we're normalizing it, so it's like we don't care whether it's make or break code. So we don't really care whether a button was pressed or released. We're just like getting what was the value. And we're returning value to AX? No? What? Yeah, so like that value was AX, but we're not doing pop AX. So it's disposed. Like AX hasn't been changed yet. We're shifting left this and then BX plus some garbage. So then we're checking whether it's 0 again. Push DI cycle BX. What? Oh, maybe like each key that is pressed has its own handler, so we're like computing effective address of that handler and then calling it. But it's like so stupid. Why do we need that? Why do we need a function for each fucking key? So I don't even want to know like where are these functions. So I think it's like let's rename it. So it's like get key value if ready. And probably if it's not even about the value, probably it's like maybe it's like do something if key is ready. Like let's do something if key is ready. Yeah, so like, and question mark, I want a question mark, and it shows that it's like returning some value. I don't really know whether it's true or not. Maybe. Yeah, it's like right here. But it doesn't really change the return value. So, other than setting it to 0, let's see. Like AX is not really affected by anything. This function returns 0 every time. Like here it's 0 and there it's probably like either unaffected or set to 0. So, does it really return anything? Probably not. So probably it's not get value if ready, because we're not really getting anything. But like I don't really care if it doesn't help to find where music is played. So let's continue. So we're checking again if key is ready. Then we're calling this key. We're throwing like AH. Yeah, this one is great. This is exactly like get key, like key as key code if ready. So get as key code if key is ready. Yeah, this is exactly doing what like we're reading here. So let's see. Jump here. And what is this one? What? Oh, the jump of not zero here. This one seems to be like exactly the same as this one. What? Jump of not zero here. Jump here. It's a like loop. Well, true. Yeah, this is a loop. Like reading keys over and over again. Jump if not zero. Here. Zero flag. Yeah, like if zero flag. Shouldn't it be like the other way? Jump of not zero here. Yeah, like this has some strange logic. But it only like uses interrupts. Whatever. So like whatever. Do we have the value of escape scan code? We can search for that. It will be more useful, I think. So we need like keyboard and shit. Let's see. Video input output. So keyboard. We need table of all scan codes we can have. So here. So escape pressed scan code is equal to 1. This is great because it will be impossible to find. So like okay, I have a brief idea. What if we'll like search RQ1? Yeah, so install RQ1 handler. It loads the value here. So this is an address of RQ1 handler. Let's see. Yeah, so what? No. Previous. Yeah, this one. So this actually like reads from the keyboard. Let's like actually see how it's done, because I also have a code that reads from the keyboard. So this is like translation table for scan codes, but yeah, so scan code is the value of port 60. Yeah, so we can like search for escape in here. So 60 if it's not a break code, if it's a make code, if we, like bvar, let's search for bvar. And UR3 is exactly bvar, so okay. If so we're saving our code. Yeah, like whatever. Some stupid shit. No, no, no. It doesn't really help because it doesn't check for key. It's like saving this is key value here. Yeah, like okay. So who cares? So like bx I think this C disassembly is wrong because like okay, this is our interrupt handler. We're reading from port. That's great. We're reading from another port, and I don't see how it's any useful. Okay, whatever. So like then we're we're reading from port. We're saving this value. So then we can like read from another port, etc. Okay. Then, and we're testing this value. So if it's if it's a break code, so break codes have like this bit set. So if it's not break code, we're jumping here. And if it is a break code, we're like ending it. So it's no longer a yeah. So it's actually makes a lot of sense. So and let me show you here. So like if it's a break code, see, we're like handling some logic of and we're doing exactly this because like the difference between key being pressed and released is like this bit that is set when key is released, but like everything else is exactly the same as in case of key being pressed. So we don't actually need like another code for handling like keys being released. So we just need a code for keys being pressed, and like this translation table for keys being pressed, because like break codes of them is like exactly same values but with like this 8-bit like this bit set. So this makes a lot of sense to me because like if it's not a break code, like this tells if key is being pressed, so we're going here, and if key is released, we're like making like preparing this value, normalizing this value, so it's we don't really care if key is like pressed or released, and like doing this shit. So let's see what this one does. So it's source, okay, so it copies this. If key is like 5A, what is 5A? 5A is it's not really 5.2, 5.3, 5.4, 5.5, 5.8, 5.9, 5A. So it's like some probably value that doesn't really exist. So like if it's above this value, it's not really like a real key that is pressed. But like why this code says it's like we're comparing to 5.9, but this says it's 5.8, because 5.9 makes a ton of sense. Like 5.8 is the last possible key, like the last possible value of scan code. So this 5.9 is first one that is like doesn't correspond to any actual key. But like what the fuck? This one says we're comparing to 5A and this one says we're comparing to 5.9. Like what? And it's like this line is this line in assembly, so it's very strange. Okay, anyway, so 5.9 makes more sense to me. We're doing this comparison, so it's like unsigned int fucking music. Unsigned int. So jump if carry if okay, I'm tending to believe that okay, if probably if carry it's mean like if it's greater. I need to see for myself. I have like a small cheat sheet of jumps. Jump if above, it will be like jump if above. Let's see. So, how do you feel about our little stream? Do you have any ideas where I might look next to find precious music? So, above, carry flag or zero flag is 0. Carry flag is 0 if it's above or equal. So carry flag is 1 is below or equal. So jump if carry means that, but like what's the order? We're subtracting 5a from bx. I don't know where to look. Me neither. So this is the part of fun. So like 5a is subtracted from bx. So bx, if bx is less than or equals to, then it's like 1. So yeah, like this is totally correct. Is it? Like, yeah, whatever. So if value is greater, then we're like setting it to 0. But if not, we're jumping here. So we're moving this value to this variable, 1 to like some other variable. And then we're testing 1 here and doing a bunch of jumps. Testing value here. And all of this is like, is finished here with iRed. Interrupts are disabled. Where is this comparison is held? Like this one. Move bx. Oh, this is like our data segment value. So bx is moved here. And it's data segment. Yeah. So like I'm fine with this value being data segment. Okay. So by the way, if you have any questions about like what I'm talking, like what is data segment or stuff, you can ask them. Yeah. So we're comparing this and this. What is AX? Like, where this comes from? Like, look at this. Let's jump. So this is kind of some kind of function. I don't really know what. Yeah. So this looks like another interrupt handler. So because we like already had an IRED. Oh no, this is like a finishing of our interrupt handler. Yeah. So this is the whole thing, I suppose. Or this is the whole thing. No, this is like... actually... So, if... see this value, A3D6, so isn't it the same as, like... we've read this and 83D4 and 83D6 BX plus, and it's 1. So 83D4, it's word pointer, so it's like 2 bytes starting from 83D4, and BX is value of AX. So let's see. But like scan code is only like a 1 byte long, so it returns 1 byte from port 60. So let's see. We have 1 byte here. Yep. So like we're saving the whole AX thing. So we've read 1 byte, saved it to the variable, then like did some other stuff we are not really interested in. It's probably like restored some mask in RQs or something, I don't really know. So but like here it's saved, here it's restored, then we're like doing a bunch of tests, figuring out whether we press key or released it. But then we've saved 2 bytes at address A3D6. So it's like A3D6. Let's see. So like word ptr where scan code is stored. So then we have a function, like after all this we have a function which does like you see, like it reads 1 byte from address that is like byte apart from this. I don't know. So it's like no, but 1 byte apart from this is like D5, but it's reading from D6, and it's reading from BP param 1. Where it's called? Let's see. It's called from here. Not really useful. It like really appears to me that this function is actually retrieving value stored by our keyboard handler. Let's search for this address. So yeah, it's but here it says it's loaded with 1, but it's like BX plus this bullshit. Which is exactly this. It's BX plus this, so it's like it should return 1. Let's skip this song, I hate it. So let's see. This looks like it gets some sort of Yeah, it's like word PTR from BP plus param1. And what's param1? Push AX. Param1 is 1E? What? So like 1E. What is 1E? Doesn't make any sense. So like for me it will be like much more clear if param1 was this value, and it's like at this address we have where a key is stored, and then we have like 1 byte which is like 1 or 0, whether key was pressed or not. So then we're checking like, yeah, whether it was pressed or not, and then doing some random shit. So probably this one like returns was key pressed. It sounds like this. So bx is like bp plus. Oh no, it's yeah. So this I'm sorry, I'm like super dumb. This means not like get value from address 1e, rather it means like get what the fuck, where I'm going. So it's like this key, it's a scan code of a key 1e. What's 1e? 1e is a. So this like this part figures out whether a was pressed, because our handler like stores 1 at address like d6 plus the scan code of a key if it was pressed. So this figures out whether a was pressed. Like this whole sequence. Not whether a was pressed. Yeah, so this is super helpful. Why? I don't really know. Yeah, and yeah, so this looks like an actual code of a driver, maybe, because 2C. What is 2C? So 2C is, yeah, it's like that. So Z is not particularly useful, but for fuck's sake, I hate this music. So like we're figuring out whether A was pressed, then Z was pressed. What is this function doing? Some random stuff. Okay, I think we're a bit off track by like trying to chase whether like escape was pressed. So if this function doesn't really if it's like it doesn't really, so here it's initialized with 0. Is it in the loop? So where? So it's not in the loop. Yeah, like at this address a scan code is stored, and here it's like whether key was pressed or not. Stalls. Yeah, and here it's like initialization of this area. So we're saying like, okay, we need to 0 initialize bytes at starting location of this. It makes like a ton of sense. So this initialization, note initializing area, like a map of pressed keys. Yeah, this makes a ton of sense. Yeah. So I like this. So this, I know that it for a fact installs this handler. So this handler writes to this area, which is like 0 initialized, and it stores which keys were pressed, and then function, like this function answers this question, like whether a particular key was pressed or not. And this is super cool. Yeah, like we know exactly what's happening. So each time key was pressed after like this callback was installed, callback like figures out whether key was pressed or released, and probably released part of this, let's see, like released part of this probably like writes yeah, it figures out whether it's no here. So it figures out whether it's a correct key or not. Yeah, and then it stores like 0. So it's super cool and obvious now. So this callback does like things that we now understand. Like, apart from this, I don't like really want even to dive into this section of like some stupid memory references, but like this is super obvious to me. So each time key is pressed, this handler is invoked, which figures out whether it I'm sorry, not like just pressed, but each time keyboard was like interacted with. So we're figuring out whether key was pressed or released. If it was pressed, we're storing 1 at this location. So it's base address plus the scan code of a key. If it was released, we're storing 0 at that location, indicating that key was released. So this is like super obvious. But so this like it's like some sort of poll function which like accepts. So we can just rename its key scan code. Yeah, so it accepts key scan code and returns something like bool. Can we return bool? Like bool. Yeah. No. Scan code is byte. It returns bool. So like was key is like key being is key. I know exactly how to call it. Is key down. So it's like 100% this function does this. It accepts key scan code. It searches in like our keyboard map whether it was like whether it's down in that particular moment, and so like probably so this reaches for key A. This reaches for key Z, so probably it searches for some kind of combination of keys. So if like AZ was pressed simultaneously, maybe it's like some action needs to be taken after that, but like it's super obvious. So what about this function? So like scan code is stored here, but H3D6 is start location of map which contains 1 if key is down and 0 if key is up. So it's like super easy and super obvious. Like how it helps, I don't really know. Because we need, so it's like int 21. What? So we're like doing some shit. Like, why can't I set volume to something like less than it's set right now? So stupid. Anyway, so like we're doing interrupts in some cases. This function looks like some game loop probably. It figures out like which key is pressed maybe. So it's not what we're looking for, because like here, where is the music here? I don't really know. So let's return back to our starting point. Now we know more about like key presses and stuff. So we know that this address for a fact is a data segment address. So we know that where like we have file names and stuff, we know where we have file extensions. So we just need to figure out, so like let's have a nice and smooth to-do list. So we're not really like need this shit anymore. So like this note keyboard operation. I don't really know why this game like uses N16 and its own callback for keys. Maybe one is used at like menu level and this one may be used at like actual game because it's faster to do that way probably. And you can like control maybe it's not really that faster, but maybe it gives you more control of like what to do in certain cases, because you can like have function is key down, so you know like for a fact whether it's right now is down or not. You don't need to like N16 it to figure out. So maybe it's more useful in like actual game where you're driving, but for menu scrolling and stuff you can use N16s because it's maybe simpler. I don't know. So this for a fact like keyboard operation, so it requires like installing IRQ handler, so we know where it's happening and stuff. Now we just need to figure out this address, because like we know this is a data segment address, so like it's where all our like global buffers and variables are stored. So we just need to find out like this arithmetic, why it's like this offset, and so like we need to do some calculations here, because it's not super like obvious, like go here and play music starting from here, because it's like two entire level of indirections. We have this BL which holds this variable, so this is a starting address and it's shifted by 1 each time, so it's like 1 2 4 8 16, and we're adding some another address because here, so we have bx added with this address. Yeah, so like let's suppose we know this starting address. Let's search for starting address, and it's nowhere to be found except for this function. What a shame. 14, like some BL is like value of from this address. If it's 0, we like turning speaker off. If it's not 0, we're playing some frequency, because yeah, it's probably like null string. It's like let's see. I don't need my cheat sheet of assembly anymore. So let's draw a bit. So like I imagine this like being like some frequency, etc., and then maybe null. So because we know that BL is like char star, so it's byte pointer. BL is itself a byte pointer, so we are like adding to the pointer some offset, yeah, and then we have like value, 2 bytes out of it. So 2 bytes is our frequency, so we're loading our PC speaker with frequency and playing music. So we just need to find out why this offset is here, which addresses is like here. So BL is like, why live stream saying that I'm not having any viewers right now? Because I think I have. Maybe it's YouTube live stream panel is broken. Yeah, like whatever. So which address is here? So this is 8A is the value of data segment. So this is like data segment. And this one is some sort of offset. So this is data segment, this is offset, so we're getting like byte PTR. So no. Byte PTR, byte PTR. And if it's 0, jump of less, if it's like -1. Sign comparison. ESSI +1 AX. So AX is loaded back to here. Then we're adding 3. No, this is like some strange math. So this is like 0A is our data segment. This is like pretty clear. So this is like value of data segment. Can we comment on that or rename or something? I want to like. Yeah, like this function sets some. What? It says 0 to this value? Yeah, like if it resets it to 0, so if it's 0 and speaker is off, maybe it's 0 if it's not our data segment, it's like 0, so we're only loading value from 8C, which is this address. So and we know like address 8C like 5F is like an uninitialized bytes, so we need some place to like 0x5F something. We need this like to be loaded with some value. Yeah, it's like too much to search. Let's see. So what's our value? 5FAD. So it's like AD. 5FAD. Like there's like many values 5F, like D4, DA. And we have AD. So 5FAD. I'm interested in like reading some files, storing the data in here, and we know like we have file names. So it's probably like files for records and stuff. We also know like we have this string, so like this string is like super useful if we find like where it's referenced. But unfortunately I don't think we will. Wait, let's actually assume like that interrupt based reading is used in menus. So let's actually see if key is not ready, then we're doing something. So if key is not ready, we're using isKeyDown function here. So it's like the same function. 1E to C. What is 1E? It's a Z again. Yeah, I think it's like wait, it's like it's entirely different function now. It doesn't have any cases. There was like cases before. What the fuck? This is some strange disassembly here. So I think I know this bullshit. So why we're using like int16 and like our handler at the same time? I don't really know. Maybe it's different functions. So we're going like something like here. Then we're checking key presses. So what this one does? It checks 83D6. You need like arrow presses to so in this game you're controlling your car by like arrow presses, and I know AZ is like some gearbox stuff, so like you're shifting gears with A and Z. So this one is probably like WASD stuff, but with arrow presses. Where's like up arrow? What? Yeah, like up arrow is also numlog 8, so it's 4 8. So probably by adding like this with our base address of key map, like this. So and like hexifying the result. 841E. So and I think it's exactly the address we're getting here. 841E. 84. It's like in the ballpark of 1D. So like here. 841D is 1D. 1E is like it's 7. Keep out 7. It's home. Home? 1E. Yeah, so this is like up arrow for sure. This one is like up arrow. So this checks for probably like some movement keys. And UR0, we're calling some other function, which does some more shit. Yeah. So I don't even want to start to read it. Like check some key presses, check if movement keys down. So like let's return back to our int16 function. So get value is ready, where it's called. So it's called here. So this looks to me as like some let's actually play this game for ourselves and see what it might be. So let's see. We need like this game, like Grand Prix Circuit Online. So I know you can play this game here. We need to mute this tab because I don't care about music right now. So this is the game, this is the menu, and AZ does nothing in the main menu, but like if you were racing, so here like Brazil, Britain, Monaco, Canada, Detroit, yeah. So this is like abbreviations for map names, and we found that in exe. That's great. So we also found like car titles here. That's also great. And you see how like how slow it is. So, but here, if we press like up arrow, which is also numpad, so yeah, like numpad 8 is forward, like yeah, 7-9 also does some stuff. It's like home and page up. Some strange shit. So it's like also doing some stuff, but AZ is for gear shift, but we need to like select different difficulty for that. So let's see. In hard difficulty, you have to shift gears for yourself, and I think it's AZ. Yeah, so A shifts up, you see, and Z shifts down, so it's perfectly fine. So we found, so okay, yeah, and this is exit to DOS by pressing escape. So we just need to find where like escape is handled, then by unpressing it, it starts intro all over again. So if we like find where this title is printed, and we find like what is happened after we like pressed escape one more time, so we are pretty much like found where intro sequence is played, and by doing that we like know where our music is loaded and played. So it's like all related. So this for a fact is hard mode driving sequence. So because we're checking like gears, so gear up, gear down, this is great. So like this is A, this is Z, this is movement keys. So this is like hard mode driving, like hard, no, like manual driving handler CB, something like that. So this is called here 5F3C 5FD8. So like 5F AD. So it's almost like it's almost our function, but not exactly. So this like some does some shit. Okay, so is it called in the loop? Yeah, so like what this one does. This one does some DE is loaded with this one. Yeah, like probably it loads like values of so our function which we are like looking for, like this one, maybe plays different frequencies based on driving. Okay, so let's continue searching for interrupt based IO. So like get ASCII code key if ready. So this one is called here. This is like a bunch of function calls. Okay. So we need like return value of this being compared to 1. So if key is 0, so if nothing is pressed, it's like exit, then basically it's like just checks whether it was pressed or not. So it's like basically it also like it's also calling our check of movement keys now. Maybe it's also something driving related, because it's definitely not intro related. So yeah, so like if this function is only called at like driving related sequences where you don't really care, but this one is called a lot, so we need to like have it some sort of name. Like this resembles some sort of like spin lock wait until key is pressed. Spin lock wait until key is pressed. No, we can just short it like that. So because it's like calls itself a bunch of times, and if this returns 1, then we return 0. If it's not, I'm sorry, if it returns 1, we return 0, so like we know that key was pressed. But we like don't care whether it was like pressed. Let's see. If param1 equals to like 4800, param1 equals to 5. So we're waiting for key presses, but like who cares? What is this one? It's like some other. It's strange that we're just waiting for a key press, but doesn't really do anything with it. So we don't really care about key that is pressed. How is that useful? Yeah, also, we know that this piece of garbage like look at this. If I press any other key except like if I press Y, this is like this exits really. So but if I press N or any other key for that matter, so like even like but except for shift and like any letter key, any number key, it's probably even shift will work because it's not a real DOS, it's just an emulator. So we know for a fact that this only reacts for Y being pressed. So, and we know like Y key code. Yeah. So we know scan code for a Y here, where it is. So Y pressed is 15. So we just need to find out value 15 nearby. Like we also have these functions, which are not even like which are not really even disassembled. So the value 15 is exactly Y scan code. So like let's search for 15. Yeah, like this one seems something like could happen. Sub AX 363 compare AX 15. So like But it's like, it's not compares for equals, which is really strange. Like, let's imagine this function is our intro sequence. But it's like so stupid. Compare AX 15B8. It's not even compare, it's add. And AX is like some kind of word from, it's even maybe a local variable, it may be like parameter. So it's not really what I'm looking for. It's a shame, because I want to know where it's like, where this whole start sequence comes. So we need some function which will output this like label, this one. So we need a function which will print it to the screen and wait for our key to be pressed. Maybe as we don't really know which key we like end up with, so maybe it's where is it? Yeah, so maybe it's here, so in one of these sheets. So let's see something which will like resemble the actual stuff. Like we need this one with result. We need the result. We need like get code, but it's an ASCII code. It destroys scan code, so it's not particularly useful. Yeah, well, unless this menu thing. So it only returns ASCII code, and it's like used only here to know whether key was ready or not. Yeah, like so stupid. Why do this if you can like? Oh, maybe it's maybe this function is like, well, we need an immediate return without actually waiting for escape. By the way, which like I have an idea. So y is 15. We know like our table 83d6 is like, we need this address. So 83eb is potential address to store like y value. Let's see. So 83eb search. So like no matches. So maybe if key wasn't pressed, if key was pressed, I wore 5. It's literally used only here, which is so stupid. Like, why this function is called only from here? Like, so this is so stupid. And get like movement keys. So we need 83eb. 83eb. So it's not even like here. But maybe it's here. 83eb. 83eb. Maybe we can find, but like our search failed, so 83eb, 83a2, 839d, 83a8, 83b4. So it's like a bunch of random values. Yeah, like this one is probably like for some other keys. Yeah, but it's also like here. Like what? So this has like the most potential, but this doesn't even count as a function. Maybe let's make it as a function, and then this one will find us like where it's called or something like that. So this one is red. 449. So it's here. Red. So this one is a function which like compress some shit. Reds. So this seems to be an entry point to other function. So let's like insert a function here. Create function. So yeah, now this is a function, but it's like no references to this one. Let's actually save. What is this? Mark current location for selection start. No, I don't need it. So we're like checking what is pressed, seeing like, okay, jump of 0. So like something was pressed, but this is like so stupid. 0 flag means that something was pressed. So let's see. Okay, something was pressed. We're moving it. We're testing 30. What is 30? Okay, let's assume it's what it was pressed. So it's B key. Okay, B. Jump of 0. Okay, if it's B, move D. And jump here. On this function does some interesting comparison. 8B, 7E. Yeah, like this is all over the place. Not particularly helpful. So if value is like 30, if something is here is equals to this one, so it's not really useful for that matter. 83AB, it's far from this address. Yeah, so let's see. I just can't figure out where like where escape is like where escape is handled even. I know that like escape we need to handle two keys, like escape, then this should pop up, and then we should handle Y. And like, okay, maybe we can search for escape being handled. So like this function is called, then we're moving 836E. 836E. Okay. 6E, it's before this one. Okay, so it's 0, then it's like 1. We're setting it to 1. Yeah, like we've tried to figure out what this one does. So it normalizes key. If it's extended ASCII and it's here, then it normalizes it. It's extended ASCII, then and BX BP. So it's like saving this function to parameter, but BP plus push AX. So like, what exactly it does? 5E. Like BP plus parameter 1. So it's AX value or... But it's small, it's not load effective address. So it's like AX value, but then we're like storing this value back, shifting left, moving 8164 to BX or in BX. If it's 0, we're jumping like to here. Restoring this, moving 0 to this byte. So like, yeah, like we can't be in this function like while we're in this function. So we're moving back. So like sometimes like these keys maybe changes like some global state, but we need to do that if only some keys are pressed. So like we're calling this function, but where this function figures out what key is pressed. So if it's 0, if it's not 0, if it's extended ASCII, then we are comparing it to like 8-4, whatever that means. So 8-4, what is 8-4 for extended ASCII? 8-4. It's 3 press extended ASCII. Need ASCII table. ASCII table. 8-4, like hex 7F 80 81 82 84. It's like some garbage letter. Maybe this one is handle is like also handler for yeah, like whatever, we're entering some name or like something like that. Yeah, but it's only, it seems to be used only here. Yeah, also this calls a function in BX. So BX is like BX, and here this address is like very interesting. So if we have a special callback, yeah, so like so this, not only it returns a value. So if like key has a special meaning, probably we have like call BX this. So this is a base address for these callbacks, so we need to like find where it's initialized. 8164. So search. Yeah, like this function is probably installs. So what is AX? AX is second parameter, and BX is something like key value. So AX is a pointer. So like this is probably install key callback, and parameter 1 is like key value. So let's try to normalize this. So this is scan code, and this is, so scan code is byte, is always byte. So this is like pointer, some like point star, like key callback. So this function is installs callbacks to. So if scan code is make code, yeah, we install callback for pressing this So, and we are calling this 2 times. First one, we're installing callback for key 70. So what is 70? This is very interesting. So what is 70? 70 is not... So it's not even a real key, I suppose. So install key callback. AX is 70. Like what does it even mean? So, shift left BX. Oh, this is too messed up. Okay, but I think it's actually how it handles escape. Oh, yeah. So here is like special keys. So this is A, this is B, this is 10, so 16, etc. So yeah. So this is very cool. Like this install special keys callback. Yeah. So and we have Y, it's 15. It's not present here, but escape is 1, and it's also not present here. So like, what is 10 even? If I'm reading, it's Q. 11 is W. So 13 is R. And how it's any useful? Okay, not Q, R. Maybe it's like useful in like actual championship. Let's try to press Q, R and see where it's like going. Okay, I'm pressing Q. I'm pressing R, it's nothing. Like, it's so stupid. Like, escape should be really the character we should like handle specially, but like what's escape? It's like 1. Escape rest is 1, so we should handle 1 as our high priority, but we're not. It's like we're installing these callbacks for key presses, but maybe shift left BX 1. And let's actually, so okay, we're like, we've remembered this one. So here is the usage code. So we're shifting left again, so because like it's some special callbacks. So like this one is call special key callback, so it's like checking if it exists, and it calls it, so, and it like handles some shit, probably returns some value, but we're not really interested in what. And like this one is actually do something if key is ready. So if like key is ready, we're like calling a special callback. And this actually takes parameter of AX. Yeah, it takes parameter. Very good. So and it calls a function at this address.
So cliche, I see the spot you throw my way. I know your name.
And let's see. It actually like calls. So we're storing 1, so we're not like interrupted or something like that. We're ready to call this function. So we're pushing a bunch of shit, calling this function, popping it. So our DINSI then we're calling function at this address, and then we're like returning, XORing, moving 0, so this can be called again, and returning. So this is obvious. For extended ASCII, we're like comparing bx to 84, I suppose, jump of less, move bx 84, so it's maybe the high value. This like is another set of callbacks, maybe for extended ASCII codes, and we're not like calling this function, so if a key has a special callback, we're calling this function, otherwise we're returning the value. So yeah, we're saving the make code for ASCII code. Yeah, so like call special key callback, but it's also like this one basically returns ASCII code for or not ASCII code. Like, what does B even mean? So we have like we've moved like this value. So this one is AX, obviously. So we're moving it to BX, or in this if it's 0, so it's extended ASCII. If it's not, we're ending. Yeah, so like interrupt 16. I need to check once again. Interrupt 16, what it does. Interrupt 16 function 0. Like, what are the return values? So if it's standard ASCII, so BX AL. Yeah, so it basically says that okay, whatever that value is, it should be normalized, bounded by this one. So okay, maybe it returns ASCII code, so it calls special callback and returns actual ASCII code. So return ASCII code. Okay, so this one returns ASCII code, this one also returns it. So it actually returns a byte in AX. Do something if key is ready, and return ASCII code. So yeah, and it's like returns byte which is in AX. So in this one also returns byte. Yeah, so it returns byte and it takes word because we're pushing the entire AX. No, vice versa. It takes word and returns byte. So this one, yeah, this is word and this is byte. Yeah, much better. Why it's not here? It's byte. Yeah, so thank you. It returns byte. Yeah, basically it returns word, but this word is like less than a byte. So we're like throwing away scan code, we're returning ASCII code. Well, because escape also has ASCII code, maybe we should like search for ASCII code of escape. Yeah, and its hex is 1B. Let's search one for 0x1B. Maybe it's like too much to search. So like, let's see. This one like moves 1B, this one compares 1B after some strange function calls. What this even does? Holy shit. It's like too much. Okay, let's traverse back from here. So this one is actually like this returns ASCII code, but is used like basically return value is ignored. Am I right? So I var. Not exactly. 8B94, and we're calling some shit. So IVAR2, yeah, it's overwritten then, so it's like throwaway value. Basically, yeah, it checks like whether key is ready to be pressed, like whether at that exact moment key is pressed. Yeah, so like it's not particularly interesting. How would I write this like in my code? So like the game is playing and all of a sudden I'm pressing like escape, so this is what happens. So like I'm playing the game normally, so like I'm doing some like shit, I'm selecting a car, I don't know, and all of a sudden I'm pressing escape, so this like moves me back, so this moves me like back still, and this almost exits the game. So like why there is no like special handler for escape key? Oh, if it's an ASCII value, so it's yeah. So I'm an idiot. If it's in ASCII value, yeah. So like this install key callback 1B. Oh shit, so close. So escape is 1B as hexadecimal. So if we are like if we want to handle 1B specially, but there is no 1B. Shit. Okay, and like this is 70. It's like doesn't make any sense. So what is 70? 70 is P. So P is handled specially. So let's see how. Ooh, P is pause. So like pause, press any key to resume. Let's see what keys like handle specially. So P handle specially. So after pressing P, it's like resetting P. So like this function, I know for a fact that this function 73, like let's see, 73C8 is responsible for printing that post message. So 73C8, let's see, it's right there. So like yeah, this should be a function. And this function is actually like pause game. So what this one is about? Yeah. So maybe this like this one looks like it's like displaying some values on the screen. Maybe 8B44. So what is 8B44? No, it's not awareness. Yeah, like this one probably like displays this post message or something like that. So it's like restores handlers back. Yeah, I'm not doing anything useful. So P, pause, press any key to resume. So like after hitting pause, we're waiting for a key which will resume our our like pause. So before that, we should like print. I'm sorry. Before that, yeah, like this becomes increasingly helpful, because if some of these functions are like related to pause, maybe. Okay, so like whatever. We're like printing this message. Okay, let's find a pause string. Yeah, it's 58A. Um, 58A, yeah. So yeah, maybe I need to search like 0x to find actual value. Yeah, it's nothing. I really think that these all these addresses are like garbage, because so how it's all here. You see, like after FFFE, FFFF, and then like this is the last byte of FFFF. So yeah, it assumes we're like in a different segment now, but it might not be true, because it might be that this segment is actually like different value. Data segment. Well, wait. What if like this value is like data segment? But it doesn't really help, because so I assume that also this one looks like it's not really real assembly, it's garbage to me. So these like some strange functions. Yeah, this is a real function. Wait. Well, not this. So, okay, this function which calls another function. So red. And this like looks like a garbage already. Like starting from here, it's not really any data. Yeah, okay. This one is red. So let's assume that garbage starts from here. So all these maybe is not real functions anymore. So let's like clear code bytes. Num1 card 3. Yeah. So it's not functions. So it's garbage. Microsoft copyright. So yeah, probably this like where data segment starts. Not like at 2, but yeah. So okay, data C strings. Runtime library. Yeah. So this clearly is not functions. So okay. Function. How do I remove it entirely? So it's not a function. Edit function. Like I need to delete it. Yeah, delete function. So subroutine. Function. Okay, like this is some like Microsoft runtime library, copyright 87. Very nice. So this is like some bunch of shits. This is not a function. delete function. And it's not a subroutine. Like what? I don't need this label. Edit label. How do I remove it? Like, yeah. This is not code. Well, now it's not a data either. Well, edit label. References. Yeah, whatever. I don't really need it, but okay. It doesn't really hurt either. So this like is last true function we have because it looks like a function. This looks like an interrupt handler for me. So yeah. So this one probably is a function. Yeah, because it has red and yeah, it's key presses AZ. Yeah, like why this exact code is presented like a function in one case, like and it's not even a function, it's like part of case. Like this is broken stuff. So if this one is data, maybe we should say that actually all these addresses are wrong now. So it's not a code segment like 1000 anymore, it's a data segment. So can we say that? So it's data. No. So I need like from this address and on say that set register values. So I need like DS to be. So I need DS to have value like data segment. Where is it? DS, DL, CS. You can have CS. But where is DS? I need DS. Yeah. So data segment has the value of what? Of this one. Okay. It still thinks that it's code, but like okay. Can I just select it like that and set register value for CS to this value? So does it help? I'd say not really, because like I say that CS, but it still like thinks that addresses are okay, these addresses are definitely wrong. Disassemble. Yeah, it doesn't really help. References. How do I say that like this address is fucking wrong? How do I correct it? Patch data, patch instruction. No, I don't need to patch anything. I need like this address to be different. Clear register, set register. So yeah, like I need CS register manager. Yeah, that's interesting. So CS. Okay. So starting from here, yeah, like this address should be like this value plus like whatever like 0000. So let's like use like this shit. So yeah, and I think I broken something. How do I undo? Yeah, so it's like before. Shit, so like all these addresses are broken. Maybe even my CS edit wasn't really necessary, so like, let's undo it for now. Yeah, like assume CS 1000. Okay, yeah, like whatever. Let's assume CS 1000. So this function is clearly not a function. Delete. Yeah, so like I need to change this address. So this address is wrong. How do I change it? Let's Google. So like Ghidra change base address probably. Not really. Probably like change segment base address. Okay, memory map. How do I work with memory map? Yeah, it's this one. So okay. Okay, it thinks that data segment starts with like here, but it's wrong because data segment is like not here. So yeah. How do I edit it? So like for example, because like all of my addresses are wrong because of that. Okay, I don't really have time for that. So let's find our actual data segment, and we'll do like recalculation by ourselves. Yeah, like all this is data segment clearly. Maybe like music is here somewhere because I'm like looking in the wrong place. So subroutine. Yeah, like let's assume data segment starts here. Address like FEDB. So like what's the difference between like fucking music, shut up. Okay, so what's the difference between like FFFF plus 1 minus like what's the address here? FEDB. So like 0x FEDB. So the difference is 1 to 5. So every address is off by 1 to 5. So actually what we want is like get our string. Yeah, like string which says, for example, let's search for pulse maybe. Or like, yeah, like exit to DOS 5878. So this is off by 1 to 5. So this address should be like higher by 1 to 5. So what, like the actual address probably should be like this. So it's probably this address we're looking for. So let's find out. 519Z. So okay, no luck. Maybe our calculations are wrong entirely. So okay, let's try again with another address. Plus 0x125 x. So it's 51AF. Like almost. Maybe we should like subtract. Yeah, we probably should subtract, not add. So let's try subtracting. So it's 4F53. So it's not this one, but maybe this one. Don't... Shit. Like, if we just knew the... if we just knew where it's actually like invoked, we'll knew. Okay, we have pause, callback. Let's search from that again. So install key callback. We have special keys. So like we know for a fact that P is 70. So it's not here. Actually, it's here. So 70, it's like 0, so we shouldn't really do anything. And after like this function is done, we should install key callback. Not really. So after this function returns this value, like we should install pause. So let's see. Okay, like game is paused, so we can pause like anywhere we want, except for like when we're here. Oh shit. Music is shit. So let's see. Like what other characters do we actually like have? So like here, install key callback. Yeah, like it's like pause and unpause. So this key is definitely pause. Yeah. So install key callback. It also installs callbacks for \n. Like for \n for no demo, please. So maybe like it's supposed to like oh yeah, like \n is actually entering a menu. So \n is value 10, of course. So can we like reinterpret these values as characters? So install key callback is actually yeah, like it's char, of course. So it's for char. It's not for scan code, it's for ASCII. So it's character, ASCII code, and void star pointer to handling function. So it's like NV, yeah, vertical tab or enter is like some values, and 10, 11, 13, and 18. And escape is like 1B. What is 18? Is cancel. 10 is... Maybe escape is like translated. Maybe escape is not like escape in this sense. Maybe it's like some of these keys and I just don't know about that. So 10 is data link escape. Maybe it's data link escape. some device control, like 13 is device control 3. Yeah, like I need to know which ASCII code is returned by like interrupt 16 function 0. Maybe I just don't really know what to look for, and I'm looking for like, yeah, like whatever. So I need a actual reference for all make codes values. I have a like full instruction reference. Okay. For registers, segment registers. So like I not really interested in this particular stuff. Privilege protection, interrupt exceptions, control registers. So like let's search for like int 16. 16. Yeah. So which like read key press? So it returns. This is like garbage. Yeah, like ASCII, but which character it returns for like actual escape key? So which ASCII character is escape key? So like, okay, maybe I'm stupid. Maybe like this page has it. Keyboard scan codes. So like what my table has for like 27 decimal, so it's escape, it's 1b, but it's not like what int 16 might return, so like it's my interpretation of that. So let's actually see what like int 16 might have for that. So this is like, okay, well, it's RQ1, we handle it, whatever. So like we need int 16. We need int 16. So we need interrupts. We need where like interrupts int 16. I know I need int 16. Like bias interrupts. I need like bias interrupts. Bias. So yeah, like int 10, int 15, int 16. Maybe like here. Wait for keyboard store can read. ASCII character or 0 if special function key. So like escape has 1b, yeah, like I think it's a table of like 61. What is 61 hex? Yeah, like exactly. So this table shows like scan codes for like ASCII codes, so it's 1b. Okay, so there is no handler for 1b as far as I know. Yeah, because like this is a function and it writes at like this location, so maybe so don't we have like okay, so this is a base location. We need no, this is not. What the fuck? So like this is the location. Yeah. So 164. Yeah, we need to add like 1b to that, so it's hex. Yeah, so this is the location for potential like escape handler. And we need to search references to that. And there is no references for escape key handler. What a shame. So yeah, I like this function. There's nothing but maybe it's like here, and BP plus local 4 is... What is local 4 even? But no, it's not like that. No. So we need like 1b to be like here. So, and pointer should be moved. So it's like, well, actually, let's see. So here we're installing like, oh yeah, but bx is also moved by 1, shifted by 1. So this should be like that. So this is real address. Yeah. So like, is it bigger than 2 bytes? Yeah, it's it's bigger than 2 bytes. So lower part of it should be something like, I don't know. Yeah, so this won't probably pop up. Yeah, like this is super wrong. Yeah, like so like what is 1b shifted to 1? It's 54. Is it operator precedence? Yeah, so I was wrong. I didn't account for operator precedence. Let's see. Okay, like if this address won't pop up, then I have no idea what to do. Yeah. So, but like these all are functions starting from 7326. Yeah, like code segment 7326. 7326. And they're like backslash n is super obvious. 7326. It's like short functions. 7326. Yeah, like this one is a function. It like moves a value and exits. So this one is a function. 1.8. So this like 2.6, then 3.9. Like this one is a function. For vertical tab. And it calls another function. So like for 11, 13. Okay, like let's assume maybe oh no, it's in 16. Maybe like MS-DOS gets it's like wrong. Okay, I need ASCII table reference because it's maybe slightly like different from current one. It will be super strange, but I need a definitive reference. Yeah, like page 512 tells about ASCII stuff and keyboard key codes. So yeah, okay. Escape exits from program or program routine. Okay. Oh, for fuck's sake, music. Okay, so like escape. So standard ASCII codes. So escape it's in binary. What? Okay, so like 1010 is line feed. So vertical tab, carriage return. Yeah, escape is like yeah, it's 1B. It's even here it's 1B, so no wonders. Maybe like these values are wrong. No, they're not wrong. Maybe like these like don't find all references to this function, so again, but 1B search doesn't really produce any useful results. It's like it should be move and push. Wait, okay, it's 1B, then it's jump here. This one does some stuff with pointers, 5E, 5E, 5FAD. I need this address. Code segments. 5FAD. Shit, it's like all this is like wrong. Okay, it's compare 1B, jump with 0, but where is 1B comes from? So it's IVAR 2, it comes from here. This function is actually okay. Two things. So first, we should like return to probably our like IRQ handler and see whether stored value like bx is what. So it reads scan code, so it's like scan code plus. So scan code for this is 1. So 1 plus 83d6 is like 83d7. So if we search for 83d7, 83d7. Yeah, like we probably haven't searched for that, because 83d7 is obviously where escape pressed will be stored, but it's nowhere to be found. 83d6 plus bx. Bx is a scan code. It's 1 for escape. Yeah, like escape is 1. PC AT key is like tilde. But it's not PC AT key, isn't it? And PC AT key for escape is hexadecimal 5A. For better or for worse, let's like try to imagine that it's true. So like this address plus 5A hex is this address. So maybe it's an escape. Who knows? Maybe it's like PCAT code, not PC. Maybe XT. What? Okay, like this seems to be so test, but it's like 1 here. Okay, this is the only reference of that address. I don't really know how key is like written here. Okay, like here it can be written, so like there we can test whether it's like special certain addresses or something like that. Okay, so if like we just wrote 1 byte here and just we're reading back, so it's 8. But like we're not storing like codes here, we're storing ones and zeros. Why it's like all of a sudden check for, and where do we go? Like where value of E3D2 is this menu. I don't know. Like I can't figure that out. That's lame. That's super lame. Like we're so close. Like we know where like special keys are handled, how they're handled, how like interrupt based input works, how like RQ based input works. So, but there is no like escape. Why? And like, okay, this function, which presumably installs. Okay, like let's rename it install pause callback. Okay, it sets like p key callback. So this function at 73C8, let's see, 73C8, like right there. So it's pause game. Okay, so but it also like, okay, it calls something, but let's not see what it calls, but rather from where it's called. So it's like some values here. Some values here. Okay. Some values here. Oh, so this looks like so like this very much to me looks like a pause function. So like what is this function? So it checks a bunch of stuff about keyboard. So it has like these states. Yeah, like whatever. Yeah, like look at this, it's huge. It's like probably it's a game loop. Maybe it handles menus. Okay, so it checks for AZ, so it's much like maybe it's for key combinations. Yeah, like looks like for some key combinations. But like here, where it's like we're waiting for key press. We press a key, where like it's not like we're installing this callback for pause. It seems like we're deinstalling it, doing some action so we can't pause again. Then we're installing it back, so each time P is pressed, we're like pausing again. But this must call for, but it doesn't call a function which like do something if key is ready and return ASCII. So it's like very strange. So when this callback is called, it's like I don't really know. It doesn't really call pause games, so it's waiting for key press. It does some stuff here. It's like we're like pushing these parameters. We're installing callback. We're waiting for a key press. So it's actually interesting. Okay, it's no, I want my ASCII table back. So okay, game is played. So we're here. I'm pressing P. P triggers pause. Yeah, like we can even like hold it. Okay. So it waits for a key press. Maybe this is like unpause or something like that. If like if we are paused. What are we switching? What like this switch case? What is the switch clause? Let's call it like that. So switch var 19. But what is var 19 exactly? Var 19, like you var 19, it's some value at FE9E. But it's parameter, it's like something passed here, no? It's local variable, yeah. So it's some value of local variable, VP plus like 9. FE9E, okay. BP plus FE9E, so it's not really helpful. What is this? 8D D6. No. Some loop. Yeah, like we're checking for movement keys. And escape is like nowhere to be found here. So like 83D6 plus bunch of addresses, but like our address is 8430, so it's not 430. No, it's not there. It's like 27. And what is 27? No, we're like figured it out. 1 is for up arrow, so 27 maybe. Some other key, we can easily find that out, but we're handling rest of the keys. So like 4,000 divided by, what is 4,000? Maybe it's a PC speaker value, but PC speaker value is actually this one. It's not 4,000. like not even close to 4,000. So it's 3/4 DC actually. Yeah, like probably we're like calculating 383B8. Okay, so one part of it is definitely this. Like 3/4 DC is 1 of 2 bytes, 2 by 2 bytes. No, it's not here. Like nothing useful is here. Why? Why? It's not fun. So like special keys, yeah, they use all this logic. Like this is P, yeah. This is cool, we know that it's P. We know that all of these keys, so this is like \n. Okay, let's like assume we know what we are doing, like 7-3, like 7-3. Because maybe it does some translation, so like 10 maybe data link escape, so it's escape like 1B. Maybe it's stall key callback. What it does actually? What maybe I'm missing something. It compares, it shifts. Nothing particular useful. I don't even want to know what this function is. So like yeah. {1,8}. So 1,8. What is 1,8 even? How do I press 1,8? So cancel. Like how do I press cancel? It's like nonsense. It's 1,8 here. But how do I press cancel? This is like super stupid. How do I press cancel? System converts if it can, sends result to buffer. However, certain districts can. Yes. First byte is 0. Second in the extended code shall figure E3. So figure E3 is extended code. If the command line to cancel or stop a running command, press keyboard shortcut Control+C. Yeah, like let's press Control+C. It's nothing because Control+C is handled like pressing Control and pressing C, and it's not Linux. It doesn't make any sense in MS-DOS, as far as I can tell. Like maybe it's just not escape returned because, well, so where like data link escape? What? It's okay. It's 8. Yeah, but ask is escape and escape seems to be like ask is exits from program or program chain. Yeah. First byte is 0 and second byte is extended code shown. Maybe it's not like it doesn't. I can just check it for that matter. So I can press escape and see exactly what's returned and what's not. It can also be tab with something called exe. No, like tab is like \t. So no, I don't care about tabs if it's a tab even. So like I wonder that every single read function from a keyboard doesn't really have anything. It's like escape is pressed and it's not really used, because like we know every single place where keyboard is read, except maybe for this one. But like what's here even? Okay, this one is different. It's like we haven't discovered it yet. So, but it doesn't have 1B values. So like it's 0xd. So okay, we're waiting for keyboard if yeah, like zero flag means zero, means that something is in keyboard, or I just don't really know how to use it. Okay, we had like Wikipedia page for that in 16H. Let's see. Also here, this one is good. So like get keystroke status. Yeah, like zero flag is zero is if key is pressed. So okay. Yeah, like okay. It's like stupid because oh yeah, but we need to remove it from buffer, it seems. So zero flag is zero. Once again, key is pressed, so we can read it. So jump 0 here. Move AX BX. In AX, it's like whole thing. Test AX 30. So AX contains 30 is space, isn't it? Or it's 0, it's maybe it's 0, like here. Yeah, it's 0. So okay, if 0 is pressed, like 0 is pressed here, so we're jumping right there, we're ending and shifting left and moving. Okay, 0. What 0 has to do with all this? So okay, like here's the game, I'm pressing 0. Okay, maybe it's in race. Okay, let's enter the race. I'm pressing 0. Okay, I'm driving, I'm pressing 0. Nothing. So 0 doesn't seem to help. Okay, let's see. So if it's 0, again here, but if it's not, we're like moving D to AX, jumping here, loading from to a no, we're comparing D to value at jump from 0, but we are returning some value at 0, like 837870. So this is some value, but when it's loaded even. So this is like some random address, it seems. So at this point, AX is definitely 30. So we're ending 30 with... But it's 0. Like, what's the meaning with... why do we need 0? So this results in 0. Why do we need it? So we're shifting left 0, it's still 0, so it's like this address. We are moving it to AX, then we're like comparing AX to a value at this address. Like, what's the point of all this? I don't really understand. Because here is like we're comparing D to this value, and here we're comparing like our so this is like this doesn't make any sense, so this is no op basically, because if like AX, oh no, I'm wrong, so it's not like so it's not like AX is 30 exactly, it's like it's not like so I was wrong a bit. AX is not 30 at this point, so we're testing because we're doing AND, so it's like, what is 30 in binary, like being 30, so it's this value. So if neither of these bits are set, so then we're going here, otherwise it's D and we're going here. So okay, let's like pretend we know what we're doing. So escape is 1B. Yep. So like 30 and 1B. It's 16, so it's not 0. Yep. So it's not 0. Because like at this point we're calling some function. So wait, I've missed like this function call. What is even going on? Yeah, like we already saw this one. So don't remember where, but like we saw these divisions. Yeah, so we probably saw this one already. It's hard. Like, I'm feeling that we're not going to finish today. And this may require some part 2. Okay, one more time. So if jump of 0, if key is ready, yeah, we're calling the function, then we're doing mov. It's not like a key code, it's like some bullshit value, I don't even know what it is. Okay, so like this is more complicated. Okay, but like if key is not available, then we're like polling we're reading key. We have another something to continue. Yeah, probably. So like we going here, this is like nonsense. Like what is this even? Some garbage opcodes, I don't even know what they are. C3 is like red, doesn't it? Yeah, C3 is red. Maybe it's bullshit, because like C3 is supposed to be red, so okay, let's disassemble it. Yeah, it's red, so, and this one is is something, okay. Yeah, it seems like it's, it's like two functions even. So it's wrong disassembly. What is 32? Okay. Let's disassemble it. Yeah, it's like XOR. So so this function actually, and this function is like totally different. Yeah, it seems like it's a bit unaligned. So like let's fix it. So let's disassemble it. Yeah, it's another in16. It seems to be like another whole function. Like this one is new function. What? Create function. Function body must contain the entry point. So yeah, this is the entry point. But like what? Okay, so this is also invalid. So let's disassemble it. Yeah, so much better. Now we're also querying for so this like is a separate function. Like this one is separate function. Yeah, like this one is just get like character and stuff. Stupid disassembly did it wrong, so it's like nothing. So probably this also wrong. Let's disassemble it. Yeah, so like it's clear that we are calling another function. We are rating, so like this may be like even. So like it's strange that we are like jumping here without function call. If key is ready, we're jumping here for no apparent reason. Like why not calling this? So this one is actually a function to which we're jumping. So yeah, like and this one is function. So like this one is function. Please create a function. But it's like what do you mean by like what is function? No, function. Create. Must contain an entry point. So like isn't it an entry point? So like already disassemble it. Like what is this label even about? So like this label is here, so we're rating. So yeah, like this one is clearly a new function, which I can't create. Probably it's a bug. Yeah, like this one is like 100% another function which is called probably somewhere. Yeah, it's like all over the place because this stuff, like checking some bullshit, we don't even know. So this one is actually just move or like this one is also about getting pressed key. So if key is like not ready, no, if key is ready, we're just like going here, we're trying one more time to get a key. Why we're trying it? Read key from keyboard. So waits until character is written, it then removes key from keyboard. Yeah, so okay, this one is poll. If key is ready, we're doing this. If key is not ready, we're waiting. So yeah, okay, I know what it is. So like get wait, like okay, do something do something if key is ready, wait for a press, like otherwise. Yeah, so this is it. So this one is like call special keyboard. So this actually pulls a key and calls for a function which actually accepts a parameter. Yeah, so this one is actually much like this one. So both of them are doing similar thing. So they're like getting a key. Yeah, like, and I can't even turn this into a function because why? Because for whatever reason I can't. So this should be a function. How do I make it a function? Function body must contain the entry point. Why it's like not an entry point? Because it thinks like this whole thing is a function, but like this is like function. Yeah, like maybe recreate. Maybe now we can create function. Yeah, so we've recreated a function, now we can. So this one actually looks much like, so jump of 0. Oh yeah, so this one is like that one, but with calling a callback. So yeah, okay, it's interesting. So like this one is actually rename function. So it's not like doing something if key is pressed, otherwise wait for a press and callback. Yeah. Whew. Yeah, that was fun. Okay, like now we know every single occurrence of int16 in our code. So yeah, like okay. How it's supposed to help us? Because like it seems yeah, like it doesn't even show proper stuff here, because it's like thinks functions are bigger than they are. So this one is a function actually, and I don't really know where it's called, because maybe it thinks of this one as a function, maybe it thinks of this one as a function, but it shows that this calls here, but like where this one is called, I don't even know. So what's its address? So it's like 60. Maybe it's called indirectly. So let's like search for address. Where are my searches? So this one is, yeah, okay, this one is here. Now actually YouTube shows that I have 1 viewer. Yay. Like, what's, yeah, like this one. Okay, let's search. Nothing. So this function exists, but it doesn't seem to be used. What a bummer. Okay, so this one isn't really used. We have 7460. Okay, maybe it's like key callback of some kind. 74. No, it's not even a key callback. This one looks a lot like pause. Yeah, this one is called from pause. So like, Maybe if I knew what is it about, maybe I can like get some insight of how this all works. So this returns some value. Okay, it's like 3:30. 3.5 hours while doing this, and we still have no freaking idea where the music is. So like, because these addresses are all wrong, I can like guarantee you that, because like here is actual like escape handler, and we can't really find it because I can't. So like we need why. Yeah, so okay, escape is not our chance today. Yeah, but maybe why? Why is 59? Wait. So stall key callback. 59. Stall pause callback. Yeah, like no, not here. So install key callback. Yeah, and after that is a function like just maybe it's somebody jumps here. Install special key callback. Yeah, 59. So 59 is apparently Y. So the only place I can like know where to look for Y is like this particular place. Like here, Y is playing actual role. So Y is ASCII 59 hex. So this one compares 59, and look what it does. It restores handlers. So like we've installed our custom handlers, so we can like react to key presses and have like timer interrupts do something useful for us. But now we're restoring it back to like whatever was like provided by MS-DOS operating system. So and return. So we're like ready to like quit. So this one, I can guarantee you that it's like exit to DOS handler. I don't know why it's called from pause game. Yeah, it's super strange why it's called from pause game, but let's see. We need some function to draw us this like rectangle with these bytes. So let's actually try to find like how it's any useful. So it calls function with like these parameters, and what's this function? It does some strange shit, but it also handles DOS errors. So it does it done like int 21? No, it's like. So let's see. Okay, it's DOS error. Maybe this one draws on the screen and like DOS errors handles. So like another function is this one. So what's this one doing? Colon backslash. So yeah, it's kind of handling for something, I suppose. So we're finding, well, Like, but we're not calling anything, so like there's no function calls, we're not reading something. Colon backslash. So okay, we're calling this function, we're doing some shit. Like, if only I knew how this game draw things, like how it draws actually. What's the method? So like we're calling a bunch of garbage here. And like if we're pressing Y, so it's actually returned by this one. So move. I don't even know what this one does. Pop, red, nope. Okay. Let's see. It compares 61 to this. Like I'm passing some variable here. Calling this function, which like makes indirect call to 85 to value at 85f8. Maybe it's like this. Yeah, like get ASCII code if key is ready. Like sounds reasonable. So okay, maybe these two functions like indirectly call our like get ASCII code if key is ready. So like we're waiting for a key, then so like okay, this one just does some comparisons because maybe we're like, yeah, like wait until key is pressed. So maybe like this indirect call is actually like goes somewhere here. So I call this one. So it's also here. So jump if not 0. Key is ready. Here we're reading this key. We jump if 0. AC. What is AC? Yeah, here. So okay. And doesn't really need to do this jump actually. So this is like some indirect call, probably it's to this one, like it's surrounded by keyboard functions like all over the place, so it's all about keyboard. It's all about keyboard. Yeah. So maybe it's like this, wait until key is pressed. So I don't know. Maybe this one reads from like BP. It's backtick or left brace? What? Okay, like here, if we press like left brace, backtick, nothing happens. So like this one is so stupid. Don't really think this one is about it. So like here. Oh, it's not like backtick left brace. It's actually a range from backtick to left brace. So like let's see, where's left brace? It's here, and backtick is here. So it's like if any of the letters are pressed, or pipe, then something, otherwise something else. Okay, let's see. So then we're returning sub 20. So sub 20. So yeah, like if it's lowercase letter or this shit, we're subtracting this, so we're in the range of uppercase letters, or like backslash or what, left bracket. So yeah, okay. It's like we're, if key is shifted, yeah, we're like normalizing it to unshifted key and actually returning what we're returning. So yeah, like we're returning the ASCII code of letter unshifted. So so it's something like two lowercase or unshift. Yeah, so this one is fine for me. Okay. So yeah, if it's like normalization function, it looks pretty nice. So we're getting some, we're reading some character. If it's so, this probably waits for a key press. I don't really know because it's like a couple of indirect calls. So jump of 0 here. Yeah, it's waiting for a key press all over again. We're calling function at this address, but let's see what function is actually installed at this address. Maybe it's something reasonable. Yeah. So we're calling this function, but this one. So look at this. It's param1, param2. I can literally figure out what is installed here. So param1. Let's actually copy. Okay, let's copy this one to here. So we know. Okay, it's called from here with parameters. Yeah, whatever. I don't feel like. Yeah. So 7885. Okay, let's search for 7885. It's probably in some range of here. 7885. 78. What I was saying? 78. 7885. Okay, here. So 7885. It's one parameter. This function is acting like it takes two parameters. 7885. Okay, 7885. It's right here. 7885. Yeah. So it's is key down. Yeah. So it is key down. Yeah. So okay, we're calling is key down because we've installed a handler. So it's stupid indirect call. So install is key down. Okay. So it's called here. So we install is key down handler. So this address is actually we just need to interpret it as function pointer or stuff. Yeah, we're installing is key down handler. Здесь, I'm sorry. Here we're calling indirect wait for is key down. Yeah, so we're calling it here because we're looping it all over. So here we're this function is actually indirect call is key down. Yeah, so this makes ton of sense. So we're waiting for a key to be down, but which one? How it reports which key is actually was pressed? So it's this yeah, whatever. So this one is installs handler, but okay. So is key down is actually reliant on our RQ handler. So why should be unshift? Should compare it to push AX. Yeah, so like AX is returned value by is key down. No, yes, no. So is key down, we need this function. So yeah, it takes two parameters actually. It takes a scan code for like, yeah, it takes, no, it doesn't take two parameters. It takes one parameter, scan code, and checks whether it's down or not. So like this one doesn't pass any parameters. Maybe it is, maybe I just don't know. So like before we're like, it's strange because we don't really pass any parameters here. So I expect like this one to return. Like how in the hell it knows? Yeah, maybe like it's wrong interpreted. So like maybe it's this function is here and it's actually like, no, it's 0, 0. So like doesn't make any sense. But what about second parameter? So it's like two parameters, one for pointer to call and another one F8. Pointer is 2 bytes. Maybe it's like hard-coded parameter, no? Yeah, maybe it's like, okay, shit. So, but like what is second parameter? Well, like push, yeah, it accepts two parameters. It sets like pointer here and maybe key to wait here. Like, like, okay, so this one is key down callback and of type like void star. Yeah, so this probably like key to wait, but like, okay, this is char. So okay, but like where it's oh, maybe it's like somewhere earlier. So yeah, what's in this stack? Push, call, move. F8. Yeah, it also like saves maybe. This is something like move AX DX. Okay. So this one returns two values, one in AX. It's actual like get current. It's like get current is key down. Okay, let's question mark this for now. Okay, this one returns two values. Okay, this one returns two values. Okay, name return. Can I return two values? So plus this one like return. Not really. But it like probably knows what I'm returning. So it's that like dx it's int signed integer length 4. So it's probably uint. Yeah, so length 4 uint. No, I haven't saved it. So like I need a type which like holds, but it's not a pointer per se. It's like tuple and sign double word. Yeah, like undefined 4 is perfectly fine for me. It's unsigned double word. So okay, it saves current handler. It like pushes new one, but it's also like we need a key. So it also returns value of like FA is DX. Okay, so FA is DX, but it's not like pushed or something. Well, like replacing this one and like this. But it's word pointer, so it's not like not really key to weights. Maybe like this function will. Holy shit, this function is huge. Yeah, this one looks like it prints some graphics because these ports, as far as I know, they're like 3C somewhere here, old graphics ports. So, okay, this one probably prints output some graphics. So, okay, we're not going to look into it, but okay, it's like ES, BX. What's ES? ES. So ES is like ES. It's maybe it's not set. C7BA. Some kind of copy. Some division. Okay. Maybe it's like draw rectangle, like 4, 9B. Maybe it's like 4 pixels, like 4, or it's like this frame is 4 pixels like high and 4 pixels here. Probably it's related to drawing this box. And any other key is like, okay, okay, PUR3. What is PUR3? PUR3. Yeah, it's like this, result of calling this function, which does bunch of shit. Okay, let's just assume. So it makes sense because if key was pressed, maybe it's like indirect. So value of, so indirect call. Okay, like indirect call is key down. It calls for is key down. So and is key down actually. But it creates like stack pointer, so checks for this and yeah, like call here. So, but if BP, what is like BP value? Yeah, okay, it's kind of fucked up to me. Maybe I just don't understand it, but like, what's this? What's this function? Install is key down for this value. What? Like, where am I even? I was like in yeah, like it definitely waits for a key press, so it's not like it probably, but it's definitely. So this one, okay, this it's like saved previous handler, so we're installed new handler, so it's return and goes back to like where it was. But what is return value? So we should like we should return some value, probably by this function. So we should like indicate that, yeah, that's it, we pressed Y, so we need to exit, but it's like from pause game, and this one is called when P is pressed. So like, what if it's truly exit to DOS handler, and this one is yeah, like maybe this is like, maybe this is exit 0, so this return is irrelevant. So yeah, like maybe after that we're calling this, and after this we're calling that. So yeah, maybe it's like exit 0. Maybe this one is exit 0 actually. Int 10. Yeah, well, like changing graphics mode. By the way, which graphics modes we're changing to? Yeah, so like whatever. Graphics mode, we're using function 0. Set screen mode, so which one we're setting to? 03, it's 16:8 color text EJ64 color. So yeah, like we're changing some graphics mode. 0B is AH is our B function. So function B is select color palette. Yeah, so like this one is truly like set graphics mode. Maybe restore graphics mode back. But like set graphics mode. Okay, like so yeah, we're restoring handlers, setting graphics mode, probably like calling some function, maybe exiting. So yeah, but like this path, like okay, we've pressed like we've pressed Y, so we've like done here. But if we pressed like any other key, like whatsoever, any other key, but then like we remove this like interact wait, and like music should begin. Yeah, like this is our starting point. So okay, whatever, this draws like bunch of like this maybe draws this box. Yeah, so probably it's for drawing. It will be interesting to find which exactly like draws. So like which one is like for like font, which one draws like those letters. So we know, we kind of know. So like this one calls some function which calls another function. Yeah, like it's probably like somewhere here. So I don't really know, and we're not really interested because we found like our handler. So this actually, so one of these functions should like start playing music. This one draws graphics. So okay, probably this one starts like, okay, we've pressed this, so we should draw like these graphics, starting to draw like these graphics. So probably like this pixel effect, but music starts playing immediately actually. So let's see. Yeah, music starts playing immediately. But okay, graphics also should be drawn. I don't think this one calls for music play, because like here it draws some letters, here it also draws some letters, probably, but this is definitely for some graphics applications. We have also this address 5FAD. Maybe it's somewhat related. Yeah, it also draws graphics. So I don't see like where's our. So okay, this doesn't call any function. This just probably draws some graphics. Okay, whatever. What this one does? This 8B44. I don't think I know this address. This does some initialization. Probably the same as this function. Was it called already? CB3. Like this one is called. Yeah, like this does some kind of initialization. But this one, what this one does? Ooh. So it's like subroutine. I can't even jump here. So okay. Bunch of garbage. Okay. So like our first parameter is. No, it's not our first parameter. It's our local variable. Moving AX, pushing AX. Probably it's not even a real subroutine start. Yeah, like maybe we're not even in the correct function. It's handled as file error. Yeah, like we're in handled as file error. What? So like this one calls. I don't think it's correct. Like let's like disassemble it again. Do you see like address here? So okay, this like these addresses and this one are like incorrect. So we're calling like 8 EA D8 D9. But what's actually called is here. But here we're calling 3C36, and like what's called is like complete nonsense. Let's actually pretend that we know what we're doing. So what's the difference between EAD9 and 8CB3? Okay. EAD9. So these bytes, EAD9 minus 8CB3 minus 8CB3. So in its hex, yeah, it's 5. Like it's this value. Okay, let's like try this one like one last time. If it's dead end, so we're like we won't try it. So difference between these two is this value. So let's have 3C36. So 3C36 plus this value hex. It's like entirely different address. Why it's calling here? It's like garbage. It shouldn't be here. So why? It's actually function 9A5C. So let's find it. 9A5C. 9A in first segment. 9A5C. So it's like it's a bit here. 9E. 9A, yeah, like 9A. 5C here. I don't really think it's correct one either. Shit. Okay, like let's skip this one for a moment. Okay, like this one happens to do something with those. But not in a way I can understand. Yeah, like probably handle doser is not like what I think it is. Okay, it's does some computation, not particularly useful. This one probably too. Yeah, so it seems like a dead end. Oh no, maybe not. Okay, like this one where it's called, it's exit to DOS handler, but okay, maybe it's let's find this one actually. So where handler is restored actually? Here it's here it's declared, here it's called, and nowhere else. Yeah. Yeah. Okay, like it's here. So this is called from here. Which itself is called from like here. Okay, this address. Interesting address. Okay, this may be something. So postgame writes 0 here means that maybe like okay, I have another idea. So it's like briefly a black screen, so maybe like rest of function exit to DOS handler just like writes black to the screen. So like this is important. Okay, it's not pause game, it's escape handler. It's like what? Why it's pause? Because it's like it's for P. Yeah. But maybe it's not pause, maybe it's escape. So like let's see. We have this one, it's like here, but maybe it's like P, but so this clearly is like yeah, whatever. This is like P. Yeah, so it's P 70 shifted by 1. But like this function maybe does some interesting stuff. Okay, so maybe it's not like pause per se, it's like it's not pause, it's maybe it's exit, maybe it's escape handler. Oh shit. My neighbors are crazy. Okay, like so we just need to know by the way, this one is also like 73BC is also a function. Okay, like so wait, so install key callback, handle extended ASCII. No. So movement keys. It's like all keyboard related stuff is here, but this is broken stuff. Okay, so it's install key callback. So install pause callback. No. Like where's the pause callback? I was there. This is probably all messed up because like what's this? Yeah, like okay, let's for this function. Yeah. Like what is this? Breakpoints. Okay, like it seems reasonable. So this one is. Yeah, like this one is actually music playing. So maybe this is broken. So we need to disassemble it. Nag. What if it's not code even? Maybe it's not even a code because it looks like garbage. Maybe it's like music. What if it's music? So okay, like let's. So like here it's the function and here it's data. Why not? Don't know. It's like red here, so like return. I think I had enough. So like I don't have any further ideas. Maybe they will come up later. So yeah, we can call it a day. We've done nothing particularly useful. We kind of know where everything happens, but not really. Yeah, so it's kind of lame. Yeah, like here's pause game, but like I'm sure I just saw another function like that. So yeah, like look at this. It's all functions, but it's all messed up. Maybe. So like here. Yeah, so okay, pause game, maybe it's pause game, maybe. Yeah, like what's this? It's exactly the same as this, but like it calls entirely different function. Yeah, like this is actually pause game. So like this one is pause game, but this one is exit. Because like we need this to be a function first of all. So this is pause game and this is exit. So in this is like pause game handler. Yeah, so it's perfect. Now everything makes total fucking sense. So this is exit, this is pause. So like why it's kind of so install key callback. We kind of see that install pause callback. It's like 73C9 C8. Sorry, 73C8. So it's kind of here 73BC. So it's like 73C8 is like is right here. It's like this 0. Maybe it's here. So okay, this is pause. It makes sense. But like this first byte is C8. Maybe it's like C 8 is actually BC. So like okay, 73BC. 73C8. What's the difference between them? It's like C. So let's subtract C from CA, like 73 CA minus C. Like, what's this about? It's BE. Okay, now let's search for BE. It's not BE, unfortunately. But it's not, neither it's a CA. So, okay, somewhere, this function is like referenced. Okay, let's see how exactly they're similar to each other. Like this, I need something like meld. Okay, like let's create a blank comparison. So, okay, like before this shit. So like here. Okay, so and then like let's go to here and before this shit. So yeah, look at this. It's almost identical. It's like, yeah, maybe length are different, maybe this one is different. So this function probably draws a rectangle. So it's pause, it's exit. Like pause one is longer, so maybe like no. So pause is way longer. But I assume that this one is an address 8, 8, 8, 8, and 9. Like length of this string is like, let's go to data section. I just want to know where's like this proper address, how to compute a proper address. So exit to DOS. Like how much bytes? Like 1, 2. Okay, it's 8a minus 78. So 8a minus 78. It's 18. Okay, it's 18 bytes. Where's 18? Yeah, it's there, but it's also there. Okay. So it's like 9, 18. 18. Where's 18? So and this one is AA minus 8a. Yeah. So it's 32. Okay. This one is supposed to be hex. No. It's in hexadecimal. Like hexadecimal. This one, it's 12, and hexadecimal. This one is 20. Okay, this is much more useful. So 12 here and 20 here. Let's see. Not really. So it's like not it's 0 terminated. It doesn't like need an address. Doesn't need a length, I suppose. So like maybe what's the difference between these two? So this one is 0e. 0e plus 12 is hex 32 is 20, yeah? Yeah, it's 20, so yeah, it's exactly this. So this is an address of exit to DOS string, and this is an address of like this post string. So yeah, like I know exactly what's an address of this one. So let's write it down. So note actual address is this one. So yeah, it's 100%. So yeah, and this for reference, actual address is this one. Yeah, so it's pretty cool. Now we know addresses. So like now we know how to compute an address of every of these strings. Yeah. maybe we know. Like, okay, so what's the value? Like, let's assume data section is set to like this one, and this one is our offset. So 5, okay, this one. So it's like 5078, 5078, and this one is 950E, like weeks 950E. So the difference between two is is this. It's like this. So probably if I like go grab this value minus this one, so like what's my effective address? It's 1B17. So it's probably address of 1B17. Let's see. 1B17. Not really. Not really. So 1B17, 1B13, 4, 5, 6, 7. It's like no, I don't think so. So okay, like let's leave it to better times. So thank you for everybody who joined me today for this like super dumb session of reverse engineering. I hope you learned something from it. Yeah, so I think I'm going to wrap it up for today. Maybe I'll continue in the future, but maybe not. Who knows? So thank you, and yeah, goodbye.